In the last video, we talked about exponential and logarithmic functions. Now we're going to talk about solving exponential and logarithmic equations. They're related clearly through the little discussion in the last video. So let's take a look at it. We'll start with exponential equations. So the key to the exponential equation, let's just bring it down here where we can work on it, is notice it's an exponential equation because the variable appears in the power, in the exponent. So it's an exponential equation. Okay, so notice my base is 2 because the variable is on this side. So my base is 2. And what I need to do is I need to convert 32 to 2 to some power. That's what you need. Now, we did some of this before, but we'll get more general. I did some of this in the last video, but we'll do more general this time. So we need to convert the 32 to 2 to some power. Okay? And you just have to guess generally. So things are going to be more general. So this is a box, right? So I want to find what goes in the box. So I'm going to take my guess, 0, 1, 2, 3, 4. Okay, let's try them out. So 2 to the 0, when that's my variable, is what? That's not what I need. I need 32. 2 to the 1, so 1 goes in the box, gives me 2. And again, that doesn't work because I need 32. So you just keep guessing until you go. So I went up to 4. So 2 to the 4, 16, and that doesn't work either. And I just did this because, I know the answer, of course, but just, if this happens, just keep going. Try 5. And we'll see, 2 to the 5th power, 2 times 2 times 2 times 2 times 2, if you work at 32. So that's it. So my power is 5. So that says x is 5. And that's it. Now each of these is going to get progressively a little more involved. Okay, so here's one, and notice the new feature here is it's not just 2 to the x, right? And this is the case. It's 2, and the power here is 3x minus 1, but we'll solve it exactly the same way. Okay, same way. And let me just bring it down. Now, again, it's an exponential equation because there's a variable in the exponent, in the power. But still, our base is 2. Our base is 2. So we have to write 32 is 2 to some power. Right? Now we just did this, of course. 2 to some power. So you have to put something in that box, 2 to some power. So again, we just did this. So I'm just reproducing the slides here. They don't work. Right, so, okay. 2 to the 5th power is 32. We just guess. So I plug 5 into the power. Okay, so 2 to the 5 is 32. Check. So now what you do is they have the same base, so the powers have to be equal. 3x minus 1 has to be 5. So that's the new feature. And you're going to get an algebraic equation here. You just solve it. Just solve it for x. Don't be intimidated. It's just going to be basic algebra. Of course, always something, right? But bring the 1 over, divide by 3, and x equals 2. There you have it. And, you can always check. There's a lot of problems in this course where you can check. So there's your equation, right, your original equation. And I'm going to substitute x equals 2 and see if it comes out to be 32. If it doesn't, I made a mistake. So that gives us 2 to the 5th power. And if you multiply it out, 2 times 2 times 2 times 2 times, it's 32, so it checks. So if you had made an algebra mistake, that's a good place to check it. Okay, now let's move on. That's the prototype of the logarithm. The exponent. Just get the same base. Now let's do logarithms. Now what we have to do with logarithms are certain properties of logarithms we need. And these are the ones I want you to know. Notice they all have the same base. If you don't have one, if you had one in a problem that doesn't have the base, there's a change of base formula, but I'm not going to make you memorize that, but that's how it works. So everything has to have the same base, okay? And then what we're doing is when we're adding two logarithms together, so see we're going to have logarithmic equations, they're going to have multiple logarithms. We want to add them. If they're adding, we want to combine it into one term, then we can use the definition. So when they add the logarithms, you multiply inside. And that's just the way it works. Notice on this rule, same base. When you subtract the logarithms, you divide inside. Again, that's just the rule. And if you have a power, if you have a constant out front, it becomes a power inside. So these are the key. It has to fit these forms. And then we're going to use the definition. These are the keys to solving our problems. Okay? So notice in order to use the definition, everything has to be reduced to a single logarithm term. The more general form, so you don't get tied up with the boxes stuff I talked about in the last video, I'm going to just call them to be consistent with what I have above, m and n. So m is going to be what's inside the logarithm, and n is going to be the power. Okay, just so it's consistent, so you don't have to get caught up in that from like the last one we did the graphing of the logarithm. Okay, and that's what I mean. You remember this slide from before. So m again is anything that goes in that box, the yellow box, n is the other box. Okay, let's just see how this works. Now this is a basic one, and each of them will get more involved. So just be patient. So notice the key here. We have to reduce it down. Every problem has to reduce to a single logarithm equals a constant. A single logarithm equals a constant. That's our goal. Okay, keep that in mind. Now, how are we going to solve that? Well, once we have this form, let me just bring it down. Once we have a single logarithm equal a number, we're going to go back and use the definition. We're going to convert it into the exponential form. But in order to do this, it has to be a single log equal a number, because notice how it works out. Just plug in, and it's x equal 3 squared, which is 9. So x is there, 3 is the base, 2 is the power. So 9, x is 9. Okay, so this is the prototype. Once we get it down to a single log of anything equals a number, this is what we're going to do. Okay, so make sure you're comfortable with this. Now compare. Notice what I have here. There's more junk in here. It's fine, we'll do it exactly the same way. We'll do it exactly the same way. But it's one log. Again, it's one log. The stuff is in there, but it's one log equal a number. Okay, that's the key. One log equal a number. Okay, so what are we going to do? Let's just bring it down here. I'm going to apply the definition. So I'm going to convert the logarithmic equation into an exponential form. Right, so you see how it converted? M is the 2x minus 1, base is 3, and the power is 2. So 3 squared equals the rest. Right? That's how it works, right? I mean, you don't have to do it this way, but that's how I do it. 3 squared. If you're uncomfortable with that, you don't. Just go back to definition. And that equals the middle stuff. Now notice what we have here. All we have here is an regular algebraic equation. 3 squared is just 9. Just 9. And we're just going to solve this for x. Add 1 to both sides, divide by 2, bingo. Now, it's a good idea to plug this back in here to check. As I said, you can often check. Here's my equation. Let's put x equals 5 in here. Right, plug x equals 5. So 2 times 5, 10, minus 1 is 9. So is log base 3, 9 too? Well, you can convert it over. It means 9 equals 3 squared. Yeah, that works. So again, it's a good way to check your work. It's a good way to check your work. Okay? Now here, we have another feature. Notice the difficulty now. There are two logarithmic terms, not one. And they're separated by a minus sign. So we have to use those properties of the logarithm to combine these logarithm terms into a single term and then solve it as we did in the last example. Okay, so there's two of them, and you can't do this directly. Well, I'm sorry, we have to see what we can do here. All right, let's just bring this down. So how are we going to combine these? How are we going to combine these? We have to use these properties. Now, which one works? I mean, just look at it. The only one that you can choose out of here is this one. You have the minus sign in there. So what we're going to do is, on the left, we have two terms, the subtraction between the two terms, and it's going to give us, right, those are our two terms. We're going to use this rule to combine it. So m is 2x minus 1. That goes up on the top. X minus 4 is n. That goes down in the bottom. So we can combine these two terms, right, the log, into a single term. And now we can go back and do what we were doing before. Use the definition. That's the key. You always have to combine the two terms or three terms into a single term. So log equals a number. Okay, now we're not done yet. Now we have to convert this to the exponential equation, right? So that's what we have. Right, m is inside, n is 2. That's this pattern, right? A is 3, m is whatever, n is 2. And we just convert it directly into this form. So notice again, it just turns into an algebraic equation. So m is here. The base is here. And n is the power. And we're just going to come back over here and insert that. And 3 squared is 9. And I'm just multiplying, cross-multiplying, multiply by x minus 4 on both sides. And just do your algebra. Distributed the 9 times x, 9 times minus 4. Put all the x's on the right side and all the numbers on the left side. So I brought the 2x over and the 36 to the other side. So all the x's are on the right side, all the constants are there. And you just solve it, right? Divide by 7, x equals 5. Okay? And again, it's a good idea to check. That's what I have. I'm going to plug in x equals 5 everywhere. And you have to make sure everything's positive, right? You can't take the log of a negative number. But in this case, it's going to be log 9, right, minus log of 1. And you can evaluate these. Log 9 is 2. We did this in a previous example. Just use the definition. 3 squared is 9. And log 1, well, I just did it here, just to show you. We did this in a previous example, I think. Anyway, that's it. And so 2. And log 1 is 0 from here. 3 to the 0 power is 1. So this is why you have to learn to evaluate a logarithm of numbers. We did that in the last video. 0. So I have that. And 2 minus 0 is 2. So it checks. Okay? So again, it's a good way to check your answers. There's most of the problems on the test you can actually check. Now here's a bigger problem, right? We have 3, and they're on different sides of the equal sign. Now, I just threw this in. It's the natural logarithm. It turns out it really doesn't matter. You'll see in the end. Don't be intimidated. The base is e. It's about 3. Just think about 3 if you get, don't be intimidated. E is about 3. So it's log base 3 roughly. But you'll see, e is this irrational number, but it'll all wash out. They always do, in all the problems they do. Okay, so log base e. And e is again about 3. So what I want to do is, I'm just bringing everything down, and I want to bring this log over to the one side because I want all my logarithm terms on one side, and I want a constant on the other. So notice I have all my logarithms on the left equal to a constant. Now that constant is 0. Now, what I want to do is you have to combine these, and you can combine in any way you want, but I found to avoid algebra errors, it's best to combine in the minus sign terms first. It's just the way, you'll get the same answer any way you do it. I just found that you're going to pay me now or pay me later. I found you'll make a little more on the log side will make the algebra easier down the road, but you'll get the same answer no matter what you do. So I'm just going to combine that, take that minus sign out. I just took out the minus sign. Now, again, don't be intimidated. Let's just go through this, okay? And there's a plus in here. Now, why? Okay, let's just go through the algebra. I took out a minus sign. Now, we'll go over it. Again, if you're uncomfortable, you don't have to do it this way. So let's just take these terms over here and take a look at it. Really, what a minus sign is a minus 1, right? I mean, a minus sign is a minus 1. Right, so really what I have is this form. And what I'm going to do is just factor out that minus 1. Right, I have a minus 1 there and there, and I'm just going to factor it out. Right, so minus 1 here times the first term gives you this. And a minus 1 times the second term gives you that. That's all I did. And then the minus 1 is a minus sign. I mean, that's what I did. And like I said, I just found that it's easier when you do this form. I could explain it in certain things, but it's just easier because I have this addition now here. So this term turns into this term. Again, the sign difference. And the reason I do this is because now when you want to combine, so we're going to combine terms 2 at a time. I want to combine these terms first by addition. So which rule am I going to use here? Just look at which rule am I going to use? That one. All right, it has to be one of the 3. So I'll use that rule. So just plop that up there and just fit everything. So m is x plus 5, so I put it over here. N is just the x, so I put it over here. And there you go. I like putting the x first. It's just my aesthetic. That's all I did here. I like the x first. So that's what I have. So I'm going to replace those 2 terms which I added by this. Okay, so that's what I did. And now notice I have the minus sign connecting those 2 terms, and so how am I going to combine those? You combine 2 terms at a time. What rule am I going to use? Look over there. Which is the rule? The one with the minus sign. Okay, so we're just going to have to fit what we have, the difference of the logs here, to the template. And you see, there you have it. M is 4x plus 6, so it goes on the top. N is this piece here, so it goes on the bottom. And so I'm going to replace this with that. And now notice what we did. We have a single log, okay, of a mess equals a number. That's the form we want. So we combined logarithms 2 at a time until we got it down to log of something equals a number. And there we have it. Now, how do we solve this? We have to convert it to an exponential, right? So here's the definition, and we have to convert it to an exponential. So let's just check that it works. M is everything in the brackets. That's M. Notice the natural log. Remember, the natural log is log base e. E is about 3. In fact, this works for any base you'll see. And you have e because it equals 0. E to the 0. I mean, the power is 0. E to the 0 is always 1. Anything to the 0 power is 1. That's what happens in all those problems. So that's your log expression. Log of something equals a number, and we're going to convert it to the exponential expression by the definition. Whenever you have e in a problem, it almost always, I think it always works out like this. It'll be e to the 0, because then it'll just turn into 1. It's just how it works. I'll cross multiply, or multiply by the denominator on both sides, and then I'll just do the algebra. I'm going to carry it up here because I ran out of space. And you'll see, so the yellow ones are the same. It's just a quadratic. And again, if you need, you can use the quadratic formula, but I'd say just try factoring it. If you can just factor it, factor it. And so a times b is 0, a is 0, and or b is 0, x equals minus 3, x equals 2. Okay, now you need to check your work. So that's what we had, x equals minus 3 and x equals 2. And you need to check. Notice if I put minus 3 in here for x, look what happens. Put minus 3 in for all the x's. Does that make sense? No. What goes in the logarithm, remember, logarithm is a function. What goes in the logarithm has to be positive. So I can't have the natural log or any log of minus 6. And I can't have any log of minus 3. It's not that x is minus 3 is the problem. It's whatever goes in cannot be negative. Whatever log of whatever is in the box cannot be a negative. So that doesn't work. That doesn't work. How about if we try x equals 2? You plug in everywhere there's an x at 2. You check it out. Now you can't do this one by your hand. I just used the calculator. So you can see I got to 2 decimal. The way v equals sign is approximately. They have more decimal places. I only calculated it to 2. I think actually if you calculate to 3, it's pretty close. But anyhow, I got about 0.69. It's close enough to 0.7, so I feel pretty confident that that works. But I did need a calculator there, so that's good. Good to go. So in this section, you should be able to solve exponential equations. So you want to get the same base, and then the powers have to be equal. And you should be able to solve for logarithm equations. It should be equations, exponential and logarithm equations. Okay? Okay, good luck.